Yes, you're done?
Yep.
Just in the nick of time.
I'm so good at chemistry, so I should look at my profession.
You should. Okay, I got a few things I need you to do. It is cold in here. Okay, so this stack right here, on exam B, I need you to look at number 55, the multiple choice. And if they have A, B, or C, then you need to just write okay on it, because I have it marked wrong.
Okay.
And then in the multiple choice section, give them 2 points back. So, like on this one, number 55, see how we marked it wrong? So just go okay, and it's minus 20 instead.
Okay.
Okay, and that's this stack. And exam A is number 23.
Okay.
Okay. This stack, I need you to total up. So I gave you a multiple choice. That is the matching. And then yeah.
Okay.
And they got a note card too. And then anything on the back. If they got the bonus, I put +1 or 2 or 3.
Okay.
So if you can total this stack up, and then third hour. No. So this hour, I'm gonna have these 2 hours. I'm gonna have you total up. This one you can make corrections, and if you want to total it up, okay. And then come back to me.
Okay. Sounds good, boss.
Okay. And that means you don't need this.
What color pen should I go with today?
Oh, whatever your heart desires.
I think we're gonna go with blue.
Sounds good. Okay, sorry about that. Here we go. Let me see if I can put this in the frame. There we go. It's kind of big, but that's okay. This is the only one that's I know. I love the idea of a document camera, but I'm just really bad at using it, to be honest with you. I'm just bad at using it. Okay, so we are going to start with combustion reactions. Let's just make it easier. So our first one is a combustion reaction. This is just easier. So we are going to be predicting products, okay? So the only kind of combustion reaction that we're going to do on these ones are going to be hydrocarbons plus oxygen. So there's a lot of different combustion reactions. So combustion reaction is any substance, okay, that combines with oxygen, okay, in the air. Now, it could be any substance. It could be a metal or it could be a non-metal, okay? When it comes to predicting products, the only ones that we are going to predict, because if we throw everything else in, it gets a lot more difficult, okay? So the only ones that we're going to predict is when you have a hydrocarbon and it combines with oxygen, okay? Always the products of this type of combustion reaction will always be carbon dioxide and water. Always. So every time you have a hydrocarbon, and a hydrocarbon is a compound that has carbon and hydrogen in it. So what the subscripts are on my carbon and hydrogen is going to vary, okay? So if you have a hydrocarbon, it combines with oxygen, that is a combustion reaction. It will always produce carbon dioxide and water. Now, of course, you're going to have to do your own balancing. So if I was to say butane, C4 H10. That's the gas that's found in like lighters, you know. Hopefully you just know about the little lighters because you light candles with them and that's it. But if you have, hopefully nobody's smoking cigarettes in here. It's bad for you. So if you have butane and it combines with oxygen, then your products will always be carbon dioxide and water. So what I'm going to do is I'm going to give you the reactants, and then you're going to have to come up with the products. And right now this is easy because this is the only one we've done, okay? So we could say propane, C3H8, which is in your propane tank if you grill at home and you don't have a charcoal grill. It combines with oxygen in the air. It produces carbon dioxide and water. Now, every combustion reaction that has a hydrocarbon will always produce those two products, always, okay? And of course, there's always, on all combustion reactions, heat and light are produced, and that's why we use them to put them in our stoves if you have a gas stove at home, or like I said, if you grill, have a gas grill at home, okay? So that's our first one, that's combustion. And I will only ever give you the hydrocarbon and the oxygen. And then you have to predict the products here. Okay, so next one, let's look at synthesis or composition. Whatever you like to, whatever you prefer to call it. Okay, so I'm gonna start slow. There's 5 types of synthesis reactions we're gonna look at. And I picked, there's actually about 8 of them out there, okay? But I just chose 5 that are the most common, okay? So the first one is going to be, let's see if I can, give me a second. See if we can get this all on here. There we go. That's a little bit better. Okay, so the very first one, synthesis reaction, if we have a metal and a nonmetal, okay? So a metal and a nonmetal on your reactant side is going to produce a binary compound. Bi means 2, binary 2 elements, okay? So, that sure didn't make it any clearer. That's a little better. Okay. So on the reactant side, if you have a metal plus a nonmetal, okay, it is going to form a binary compound. So that means the 2 elements that were on the left-hand side are going to come together to make a single compound. So if I have sodium and chlorine, I'm going to put the 2 together to make an ionic compound. We call it a salt as well, okay? So we're going to make sodium chloride. Of course, I have to check my oxidation numbers to make sure my formula is correct. Sodium is +1, chlorine is -1. So do I need subscripts? No. Does my formula need to be balanced? It does. So what coefficient goes here? 2. And then where else do I need a coefficient? In front of the sodium. Very good. So that's our first one. On your reactant side, if you have a metal plus a nonmetal, they're going to come together and they're going to make a single ionic compound. The next one, okay, I'll give you a sec to write it down. If we have a metal oxide, again, this is on your reactant side, we're going to have to come up with the products on our own. If we have a metal oxide, so metal combined with oxygen, and it combines with water, so the metal oxide plus water will always form a metal hydroxide. So the atoms just rearrange, and what we're going to do is we're going to come up with the compound. So if we have a metal oxide plus water, we will always get a metal hydroxide. So your polyatomic ion list is going to be pretty important to you. Is there kind of a glare there? That sure didn't help, did it? Not really. Okay, so let's predict the product. Metal oxide plus water forms a metal hydroxide. So I'm going to take the metal that I have as my reactant, and I'm going to start with him. It's a metal hydroxide. Does anybody remember the formula for hydroxide? OH. OH. We'll add our 2's if we need. Okay? So now I have to check my oxidation numbers. So barium is +2, hydroxide is -1. So who needs the subscript? Does barium or does hydroxide? Hydroxide. He's a polyatomic ion, so what does he get encased with? Parentheses, and my subscript 2 goes right here. So now the question is, do I need to balance it or is it already balanced? I've got 2 hydrogen, 2 hydrogen, 2 oxygen, 2 oxygen, so I'm good. Okay? So our next synthesis reaction, and again, these are all synthesis reactions, so every single product will just be one single thing. So our next one is a metal chloride. So on our left-hand side, if we have a metal chloride, that's a metal, any metal, and it's combined with oxygen, okay, or, geez, where did that come from? Chlorine. So if you have a compound that has a metal and chlorine together, that's considered a metal chloride. When it combines with oxygen, it will always form a metal chlorate. So a metal chloride and oxygen, technically what kind of reaction is this if it is combining with oxygen? It's really combustion, right? That's why we're not adding all the extras to combustion, because they're basically right here. Okay, so if we have a metal chloride and it's combining with oxygen, we're always going to get a metal chlorate. So I take the metal that I have on my reactant side and I take it over to my product side. So that's calcium. And I find the formula for chlorate on my polyatomic ion list, which is Cl O3. I got to check my oxidation numbers. What's calcium's oxidation number? 2. And what's chlorate? -1. So who gets the subscript, calcium or chlorate? Chlorate. He's a polyatomic ion, so what needs to go around him? Parentheses. And my subscript 2 goes right here. So now I have to see, does it have to be balanced? So I've got 1 calcium, 2 chlorine, but I have 2 times 3 is 6 oxygen, and only 2 oxygen here. So what needs to go here? 3. So our next synthesis reaction, something sticky on my desk, is a metal oxide. So if we have a metal oxide and it combines with carbon dioxide, so metal oxide, and it doesn't matter what the metal is. This one just happens to be iron. It could be calcium, it could be potassium. If you have some sort of metal oxide and it is combining with carbon dioxide, it is always going to form a metal carbonate. So metal oxide plus carbon dioxide will give us a metal carbonate. And we'll do the same thing that we've done before. We're going to take the metal from the reactant side. Okay, so our metal is iron, so I'm going to take him on my reactant side, bless you. And I'm going to combine it with carbonate, which is a polyatomic ion. What is his formula? CO3. Okay, there's a trick here, because remember how iron has more than one oxidation number? Remember how it could have a 2, a 3, or a 6? Okay, this is how you figure out what it is. You go back to the reactants and we figure out what oxidation number it is, okay? So if oxygen is -2, if we only have one iron atom, what does his oxidation number have to be over here? Has to be +2. So if he's +2 on this side, he is automatically +2 on this side, okay? So I'm gonna put my +2 here, and what's carbonate's oxidation number? -2. So does that compound need any subscripts? No. Now let's see if it has to be balanced though. So we have 1 iron and 1 iron. We have 1 carbon and 1 carbon. We have 3 oxygen, and we have 2 + 1 is 3. So it doesn't need to be balanced. So my last one is if we have a metal, any metal, combining with oxygen, we're going to form a metal oxide. A metal oxide is just a metal with oxygen, okay? So again, this guy's also known as what type of reaction? I heard it. It's also combustion, right? So any metal plus oxygen will give us a metal oxide. So I'm going to take my metal from the start, and I'm going to put him in my product, and I'm just going to combine it with oxygen to make a compound. And I'm going to check my oxidation numbers again. What's sodium's oxidation number? +1. And what's oxygen? -2. So who needs the subscript, sodium or oxygen? Sodium needs a 2 right here. And then we're going to check to see if it needs to be balanced. So we got 2 sodium here and 1 here. Let's do oxygen first, right? So if we have 1 oxygen here and 2 here, to get to the oxygen, don't I have to put a 2 right here? So that gives me my 2 oxygen, but it changes my sodium to what? So I need to put a 4 right here. Now, this is going to be your best guide, and we'll start predicting products. Well, we're almost halfway done. We still have 2 more reactions to do Tuesday when we get back. So we'll start practicing predicting a lot more. Okay, so that's synthesis. So now we're going to look at the opposite and look at decomposition reactions. Okay? If you remember, they are exactly the opposites of a synthesis reaction. Okay, so decomposition reactions, you always start with one thing on the left-hand side, and then it's going to break into several things. It could be 2 elements. It could be a compound and an element. Okay, so these are the guidelines that we're going to go by. So if we are starting with a binary compound, that's just a compound with 2 elements in it. And we call these salts as well. Okay, so if we have a binary compound, it is going to break down into a metal plus a non-metal, because that's all I've got. I don't have any options on this one. So if I have a binary compound, the only way it can break down is to break into its individual elements. So I have barium and chlorine, so it's going to break down, and I'm going to end up with barium by itself. The and means plus chlorine. What's special about chlorine all by himself? Needs a 2, he's diatomic. And then we check to see if it needs to be balanced. And I heard no, and you are correct. So a binary compound is a compound with just 2 elements. When it decomposes, the 2 elements are just going to split apart, and a plus goes in between. So our next type is if we have a metal carbonate. So a metal carbonate, so metal combined with carbonate will break into a metal oxide and carbon dioxide. Give me a second to write that down, then we'll predict the product here. So metal carbonates will break into a metal oxide and carbon dioxide. So I'm going to start, don't forget the and means plus on all of these, the and means plus. So a metal oxide, so I'm going to take the metal that I have on my left-hand side and I'm going to combine it with oxygen to make my metal oxide. Now before I go further, I'm going to check my oxidation numbers. Oxygen is -2. Calcium is +2. Do I need any subscripts? Okay. And carbon dioxide, that's CO2. So now I'm just going to check my balancing. I've got 1 and 1, 1 and 1. I've got 3 oxygen here. 2 plus 1 is 3. So metal hydroxide is next. So if I have a metal hydroxide on the left-hand side, it is going to break into a metal oxide plus water. And I would not expect for you guys to memorize this like straight away. I would go back to your notes and use these when you start predicting products. And then once we practice this and we're good at it, then you're going to have a lab, you'll have a stations lab that you will do the reaction and I'll give you the reactants and then you have to come up with the products just by observing and going by these rules. So a metal hydroxide, a metal combined with hydroxide is going to break into a metal oxide and water. So I take the metal from this side and I combine it with oxygen. Before I go further, I'm going to check my oxidation numbers. Oxygen is -2, sodium is +1. So who needs the subscript? Sodium and water. So then again, I'm going to check my oxidation numbers, or not oxidation numbers, my atoms to see if I need to balance it. I've got 2 hydrogen and 1 here, 2 sodium and 1 here, and 1 plus 1 is 2. So what needs to go right here? Very good, 2. And now it's balanced. Okay, 2 more. Metal chlorate. So metal chlorate, so a metal combined with chlorate is going to produce a metal chloride and is plus oxygen gas. So all metal chlorates, whether it's potassium or lead or iron, whatever the metal is, if it is combined with the chlorate in a compound, it is going to make a metal chloride, so that's a compound, and oxygen gas. This looks like there's a glare on that. There, that's better. Okay, so let's put this together. A metal chloride, so I'm going to take this metal, and I'm going to start with him, and I'm going to combine it with chlorine. I'm going to check my oxidation numbers. So chlorine is -1, potassium is +1, plus oxygen. What's special about oxygen on its own? Excellent. And then we just have to see if we need to balance it. We've got 1 and 1, 1 and 1, 3 and 2. So it's oxygen that needs fixing. So what do we want to put in front of our potassium chlorate? I'm going to put a 2. And then I'm going to come here and have to put a, and here I'm going to have to put a, you guys are rock stars. The very last one, I had to erase my, so a metal oxide is going to break into, metal oxides are going to break into a metal and oxygen gas. Again, and is plus. So if we have BaO, barium oxide, so a metal oxide is going to break into, and this is essentially the same thing as number 1, but you've got oxygen. So metal oxide is going to break into the metal. So whatever metal I have, I'm going to start with that. Plus oxygen gas. And again, what's special about oxygen on its own? Needs a little 2. Balanced or not balanced? Carly, where should I put a coefficient? Excellent, and that is correct. And that's it. Those are the easy ones. We'll get to the harder ones when we get back. I'll just kind of see how, what time are we out of here? 06 or something? 07. Okay. So what I'm going to do is I'm just going to let you work away on that assignment and get as much done as you can. And then I'll kind of assess and see how far everybody is. And if we need to move the video to a different day and finish it tomorrow, I can do that. Or start the video tomorrow and finish it on Tuesday, I can do that. Okay? Did everybody grab it from yesterday? You didn't grab the assignment? There's one in the green folder.
You see it. I can see it all the time.